Hey guys, this is IM3 Unit 3 Notes number 9, Signs of Trig Ratios. Go ahead and write down this FLT here, and then we'll go ahead and get started. So, given conditions, you're going to be able to determine which quadrant the angle is in. So, this is where the trigonometry kicks in. Okay, you may not have seen this in Integrated Math 2 or even Integrated Math 1 here. So, this is where it's a little bit new. We're going to dive in a little bit deeper, okay? So what I want you guys to do right now is to list all of the trig ratios that you remember. And I'll give you a hint. There were a total of 6, okay? Write them all down and then press play when you're ready. Okay, so I know that there's sine, which is opposite over hypotenuse. Notice how I put an angle there, theta. Cosine of theta is adjacent over hypotenuse. And tangent of theta is opposite over adjacent. Don't just write tan, don't just write cos, don't just write sin there, okay? Make sure that you guys follow a trig function with some type of angle. In most cases, theta, okay? There was SOHCAHTOA here. We have our SOHCAHTOA. Okay, and then I introduced you guys 3 other functions, the reciprocal functions here, okay? So in order, if we put it, the reciprocal of sine is called cosecant, which is really hypotenuse over opposite. Secant, which is the reciprocal of cosine, so that's hypotenuse over adjacent. And cotangent, which is the reciprocal of tangent. That one's easy to remember, which is adjacent over opposite. And again, they are just the reciprocals. Remember, reciprocal just means that you're switching the numerator and denominator. Okay? So keep that in mind. Here we go. So the reason why we explore a little bit more is because, you know, in geometry or in integrated math 2, your angles were always acute. This theta right here was always something that was less than 90 degrees. What would happen if your angle expanded beyond 90 degrees, right? In fact, it can go all the way in a circle. So if you guys just think about it, if we were to open up our angle all the way over here, how big is that angle there, right? And we can answer that in a second. But what if we continued and we went all the way back to where we started, right? What is it called when you go full circle, right? How many degrees is that? So here, you're going in a full 360 degrees, right? Okay. And what you started at was at 0 degrees. So again, you know, draw it out for you. If I only go halfway or a half circle, how many degrees is that? That's just 180 degrees. So I'm going to put 180 degrees right here. Now, what if you only travel half of that? Right up here, it would be 90 degrees. Okay, here's another one. What if you were to go that much? Press play when you're ready. So that right there is actually 270 degrees. So if you notice, every quadrant, you're traveling 90 degrees. And 4 times 90 is 360, right? Okay. So that's the first thing that you guys want to tackle, okay? This is leading up to what you guys may have heard of. It's called the unit circle, all right? But more on what it's for and how to apply it later, okay? So what we have to figure out is, well, it's important to know what the signs, SIGN, okay? what the signs are going to come out to, whether it's positive or negative, okay? So easy way to remember this, and again, you know, I normally show you the logic behind it, but I will get to that when you guys have enough information. So as we move on, you're going to be able to see why things are the way that they are. It's not just a rule that Mr. Lee made up, okay? Or mathematicians. So for now, here's what we're going to do. So notice how I started here on the positive x-axis and I went in this motion. What do you guys call this motion? Right? Okay. Now, if you're familiar with that direction, we can't say, oh, I'm going left, because eventually I'm going right down below, right? So that's not a good term to use. We shouldn't say we go left or we go right. So if you guys have ever watched a clock or dealt with any type of spin, this is going against what a clock does, so we call this counterclockwise. Okay, so notice how we always go in a counterclockwise motion, because we're going against the clock. Clocks normally go in a clockwise motion, so we're going in the other direction, okay? And the rationale behind that is, you know, your angle opens up and eventually your angle right here becomes that triangle. Okay, that's what we're leading up towards. You don't have to draw that out. Okay, so there's a system to kind of easily remember it. And again, it will be explained later when you guys know more. Okay, so for now, just try to follow and understand how it works, okay? So I'm going to go ahead and label this A, and I'm going to go in a counterclockwise motion. A, S, T, C. And you want to write it in a counterclockwise motion. A, S, T, C. So first things first, you guys have to know your quadrants. Okay? So know that when you're going from 0 to 90 degrees, this is quadrant 1. Okay? That's just a Roman numeral. If you're over here, somewhere between 90 and 180, you're in quadrant 2. Okay? Notice how I'm going counterclockwise as well. If you're somewhere between 180 and 270, you're in quadrant 3. And if you're somewhere between 270 and 360, you're in quadrant 4. IV, Roman numerals, okay? So know your quadrants. We have 4 quadrants here. Okay? I should erase that so that it doesn't look too crazy. Okay, so here's the phrase that you guys have to remember, okay? Or that'll make things easier for you. ASTC. And I'll write it over here. All students take calculus. All students take calculus. Okay? Now, although that's neat, what the heck does it stand for, right? So first, it helps you order the letters, okay? Remember, you're always going in a counterclockwise motion. So all students take calculus, ASTC. Okay? Now the next step is, what the heck does that mean? Okay? All right, so what this is saying is, depending on which quadrant you're in, it's going to tell you what's going to come out positive. Okay? So, suppose you're in quadrant 1. Okay? This is saying that all trig functions will come out positive. Okay? So, let me give you guys an example. On your calculator, if you were to type sine of anything in between 0 and 90, sine of 32 degrees, or cosine of 48 degrees, or tangent of 79.2 degrees. I want you to go ahead and type those into your calculator. And you're going to notice that all of those come out positive. And it's because that you're in the first quadrant, okay? So all trig functions will come out positive. Okay? Okay, so let's keep going. Now, what if you were in quadrant 2, right? Somewhere between 90 degrees and 180 degrees. The letter we have here is S. And S, although we said students, S, T, and C, think about where you guys have seen those letters. S, T, and C. S, T, and C refer to the original 3 trig functions, sine, cosine, and tangent. So what this is saying is that if you're in quadrant 2, the only thing that's going to come out positive is sine. Okay, so let me give you some values to play with on the calculator, okay? The sine of 114 degrees, notice how 114 is somewhere between 90 and 180, okay? Sine of 114 degrees, if you type it into your calculator, it will come out to some positive number. If you do sine of 132 degrees, it will come out to a positive number. But what if you were to take the cosine of 132 degrees, right? Let me go ahead and type that here. And make sure you're in degree mode, okay? The cosine of 132 degrees is negative 0.669. Notice how that came out negative, right? In fact, if you pick any angle in between 90 and 180 and you're using anything except sine, it's always going to come out negative, okay? So for instance, the tangent of 92 degrees. 92 degrees is definitely in between 90 and 180, so we're in quadrant 2. So since this is sine's quadrant, tangent is going to come out negative. So if I type out 92 tangent, I get negative 28.636. Okay? Okay, so this neat little phrase, all students take calculus, is a very fast way to figuring out if your answer will come out positive or negative. Okay, I'll say that one more time if you want to write it down. The whole all students take calculus phrase is to help you determine what the signs come out to for your trig ratios, if it comes out positive or negative. Okay, so in quadrant 3, we'll speed this one up here. The only thing that comes out positive in quadrant 3 is tangent. Okay, so any trig function in quadrant 3, if it's tangent, for instance, and you guys definitely verify this, okay? Tangent of, I'm going to pick an angle somewhere between 180 and 270. Let's do 222 degrees. If you type that in, you know it's going to come out positive. If I type out the sine of 184 degrees, which is like right here, you know that's going to come out negative because only tangent can be positive there. Okay? Okay, so last one, you're probably guessing already. If you're in the 4th quadrant, if your angle is somewhere between 270 and 360, the only thing that's going to come out positive is your cosine function. I should write cosine, but let's just write COS. So, for instance, the cosine of 352 degrees, if you type that in your calculator, you will get something positive. Whereas if you were to type the sine of 352 degrees, you'll get something negative because the only thing that's going to come out positive in quadrant 4 is cosine. Okay? Tangent of 293 degrees should come out negative because only cosine will come out positive there. So before you move on, make sure you can answer this question. Do I know what the purpose is for the phrase, all students take calculus? What does it tell me? Okay. Press play when you think you have it. The whole idea of all students take calculus, it helps you determine if trig ratios are positive or negative. That's really it. Okay? Now, why is that so beneficial? You guys don't know enough yet. Okay? But we're working towards that. Okay? So let me go ahead and squeeze in another page here. So I'm going to give you a barrage of questions here, okay? So some things to note, okay? Let's call this example 1. Let's write determine the signs. Okay? So S-I-G-N-S, signs, okay? So here's what we're going to do. I'll give you an example. So let's say we wanted to figure out the sine of 192 degrees, all right? Without a calculator, okay? We'll get to the calculator parts later, but for now, you guys got to understand why things are the way they are. So in my mind, or in your mind, you want to have your unit circle kind of in place. So remember, we go from 0 degrees to 90 to 180 to 270 to 360. Later on, you're going to find out that these angles are called quadrantal angles, okay? Okay, so in my head, I'm thinking, okay, let me figure out where I am, okay? Which quadrant am I in? So 192 degrees is somewhere right here in between 180 and 270. So I know I'm in quadrant 3. And I know that all students take calculus, T. So tangent comes out positive. So I know that this will come out negative. And the way you guys write it out, okay, is less than 0. That means negative. Think about it. What numbers are less than 0? All the negative numbers. Okay? And then that's it. Okay? So here we go. I want you guys to go ahead and do the next few. Let's do cosine of 300, tangent of 260, sine of 179, sine of 42 degrees, and let's do one more, tangent of 93 degrees. Okay, go ahead and answer these these next 5 real quick, and press play when you're ready. Okay, so here we go. First, you look at the angle. 300 degrees. That's somewhere in quadrant 4 because it's in between 270 and 360. And cosine comes out positive, and since you're dealing with cosine, it'll be greater than 0. Why? Because all numbers that are greater than 0 are called positive numbers, okay? All right, let's keep going. 260 is right here in between 180 and 270, so that's quadrant 3, and it's tangent. So tangent is positive in this section, so we know it's going to be greater than 0. All right? Okay, let's keep going. The next part, we have sine of 179 degrees. 179 degrees is somewhere right here, somewhere between 90 and 180. So sine of 179 degrees in quadrant 2. In quadrant 2, only sine is positive, and we actually have sine here, so that's going to be positive. Okay? Sine of 42 degrees. 42 is somewhere in here, quadrant 1. And we know in quadrant 1, all trig functions will be positive. Okay, here's the last one. 93 degrees is somewhere between 90 and 180. So we're in quadrant 2, and only sine is positive, so tangent will have to come out negative. Okay, so that's the first idea. All you have to figure out is if it comes out positive or negative. So first step is, what quadrant am I in? And do I have something positive or negative? Okay? Okay, so here's a question for you guys. And please do answer it on your own, okay? If I were to tell you the function sine, right? Think about the sine function. Let's think about this a little bit backwards now. Sine will always come out positive when, okay? So I'm going to write this out so that you guys can see it. Sine will come out positive in quadrants, and then you guys fill in the blank. Sine will always come out positive in what quadrants? Okay, so we know that sine will come out positive specifically in quadrant 2 because that's sine's quadrant, but also in quadrant 1. So sine will come out positive in quadrants 1 and 2. Okay? So let me flip that for you guys. Sine will come out negative in what two quadrants? Think about that right there, okay? When will sine come out negative? Okay, since sine is positive in quadrants 1 and 2, sine will only come out negative in quadrants 3 and 4. I should say 3 and 4. Okay, now the next few I'm just going to ask you guys, make sure you guys answer it. When will cosine come out positive? Press play when you're ready. Cosine will come out positive in quadrants 1 and 4. Okay? When will cosine come out negative? Cosine will come out negative in quadrants 2 and 3. Okay, and I'll do one last one with you guys. When is tangent positive? Tangent will come out positive when? Tangent will come out positive in quadrants 1 and 3. Okay? And tangent will come out negative in quadrants 2 and 4. Okay? So as long as you have this in your head, you should be able to answer it. Okay? And again, it's new, so it's going to take some getting used to. So here we go. Here's the next example for you guys. Go ahead and write it down. Okay, we'll call this example 2. Write its entirety, and then we'll shorthand everything after, okay? In which quadrant does theta lie if the following statements are true? So here it says sine theta is greater than 0, right? Sine theta is greater than 0, and tangent theta is greater than 0. Okay, first thing, remember what greater than 0 means. That just means positive. All numbers that are greater than 0 are positive. So this also means positive, right? Okay, so let's answer this one at a time. It's kind of like a guessing game, you guys. You have to narrow down your clues, okay? So we're trying to find out what quadrant is sine and tangent positive, okay? So let's just start off with sine. When is sine positive? At what quadrants is sine positive? Okay, and I'll draw this out for you guys so you guys can see. Sine is positive in quadrants 1 or 2. Okay? So we started with 4 quadrants, we narrowed it down to 2. Okay, but out of these 2, in quadrants 1 or 2, where is tangent also positive? Okay, so tangent can only be positive if you're in quadrant 1. So your final answer is quadrant 1 because that's the only time where sine and tangent will be positive. So again, it's a guessing game and you're narrowing it down. Out of the 4, can you think about where you are or where that angle is? Okay, let's try another one. Here's part B. So just write this statement down here. You don't have to write the top part because it's the same thing. Okay, so some things that tend to throw people off that I want to talk about are the inequality signs, okay? So sometimes students get less than and greater than mixed up, and that's perfectly fine. Just remember that if it looks like an L, it's a less than symbol. So this is less than 0. What numbers are less than 0? That's really all the negative numbers. This is not an L, so that's definitely greater than, so that's positive numbers. Okay? So here we go. Guessing game again. We have 4 quadrants. We have to narrow it down to 1. So I'll start off with this. Where is tangent negative? So it can't be the first quadrant and it can't be the third quadrant because that's where tangent is positive. So we're down to quadrant 2 or quadrant 4. Okay? So we have this, but then we have to narrow it down to 1. So in quadrant 2 or 4 is cosine positive. Cosine can only be positive in quadrant 4 because in quadrant 2, cosine is negative. So we know our answer is quadrant 4. Not a lot of work to be shown, you guys, okay? So we were able to narrow it down, okay? Some of you are going to be able to just look at the whole problem and think it through. My way is you're doing it one step at a time. It's really whatever works for you guys, okay? But don't just guess. That's the last thing you want to do, okay? You want to be able to justify your choice, okay? It should never be a random guess. Here's part C. Press play when you're ready. Okay, so I'm trying to find out where sine is negative. Sine is negative in quadrants. Sine is negative in quadrants 3 and 4. So I know it's not 1 or 2. But cosine, let me write this down before I forget. So in quadrants 3 or 4, but cosine has to be positive, so I know that it has to be in quadrant 4. That's it. Okay, let's try another one. Press play whenever you're ready. Okay, I noticed that sine has to come out negative. So that means that we're in quadrants 3 or 4. But cosine also has to be negative, so that only works if I'm in quadrant 3. Okay, now you guys, we went through 4 examples. If you're not seeing it, you gotta let me know. okay? Because the future lessons rely on what we know here. So make sure that you guys get it, okay? Okay, so before I jump on to the last few, remember how we had 6 trig functions, not just 3, okay? So how does this work with the other 3 trig functions, okay? So here's my question to you. How were these functions related? How are they related? And I want you to pay attention to the words that you're using here, okay? How is sine related to cosecant? How is cosine related to secant? How is tangent related to cotangent? The proper term is that they are reciprocals. And here's the reason why I emphasize this here. Reciprocals means to switch your numerator and your denominator, which is the reason why sine being opposite over hypotenuse becomes hypotenuse over opposite. So here's my question to you guys. I just need some space here. Hold on, let me find. Okay, so quick side note about reciprocals, just so you guys know. So for instance, 2/3, the reciprocal of 2/3 is 3/2. Okay. 1/4, the reciprocal is 4/1, or just 4. Okay. 5/8, the reciprocal is 8/5. Okay. Let me do some more now. -5/4. The reciprocal there is 4/-5. Okay. -3/7. The reciprocal is 7/-3. I'll do one more. -2. The reciprocal is -1/2, or 1/-2. It doesn't matter. Okay. So when you're dealing with division, it doesn't really matter where that negative goes because your overall answer will be the same. And just to illustrate that, for instance, like 9 divided by -3 is the same thing as -9 divided by 3. Okay, you still get a -3 at the very end, okay? So it doesn't matter where you put that negative, all right? So here's what I want you to notice. We had 6 problems here. 2/3 started off positive. And when we took the reciprocal, it ended up positive. 1/4 started off positive. Reciprocal was also positive. 5/8 started off positive, and the reciprocal came out positive. -5/4 was negative, and then once I took the reciprocal, it was still negative. -3/7 started off negative, and it ended up negative. -2 ended up as a -1/2. Here's my question to you guys. Does the reciprocal change the signs? Does the reciprocal change the signs? Okay, so look, reciprocals do not change signs. There's a unique word for that in math. We call it opposite. So it's important that you guys don't get these two words mixed up, because, for instance, the reciprocal of 5 is 1/5, but the opposite of 5 is negative 5. So don't use these two words interchangeably, okay? Reciprocal means that you're switching your numerator and denominator. Opposite means that you're switching the sign, okay? But the big takeaway right now is make sure that you guys understand this part. Reciprocals do not change signs. So here's what I mean. Let's go back to this circle here, okay? If you're in quadrant 2 and only sine is positive, what do you think happens if I'm looking at sine's reciprocal function, cosecant? Will cosecant in quadrant 2 come out positive or negative? Think about that and then press play when you're ready. Since cosecant is the reciprocal of sine, then cosecant will behave just like sine because the signs don't change, S-I-G-N, okay? So if sine comes out positive here, cosecant will come out positive as well, okay? And in the third quadrant, where only tangent is positive, its reciprocal cotangent will also be positive here. And in the fourth quadrant, if cosine is positive, then you know its reciprocal secant will also be positive. So make sure that you guys consider all 6 trig functions. Okay? So here's how we do it. If I can get to it. There we go. We're on part E. Here we go. Same instructions, except they give you 2 different statements here, okay? So here's what you guys do. You start off with one of them, okay? So you think about the reciprocals. Here it says cotangent is greater than 0. That means that cotangent is positive. So if cotangent is positive, so is its reciprocal, tangent, right? Because when you flip something, the signs are still the same, right? 3/4, if you flip it, it's 4/3. It's still positive. So if cotangent is positive, so is tangent. And I know that tangent is positive in what 2 quadrants? Quadrants 1 and 2. Sorry, 1, I can't count, 1 and 3. So I'm either in quadrants 1 or 3 right now, okay? And then we have this extra clue. Cosecant is positive. So think about what it's related to, okay? Cosecant, I know, is the reciprocal of sine. So I know that sine will also come out positive, okay? So out of quadrants 1 and 3, out of quadrants 1 and 3, where is sine also positive, right? Which one, quadrant 1 or quadrant 3? Press play when you're ready, okay? Sine will also be positive only in quadrant 1 here. So there you go. Again, you're just narrowing down the clues. Until you figure out your 1 quadrant, okay? All right. I think this is my last one. I got 2 more. Okay, let's do this real quick. Part F. Answer when you're ready. Okay. Cosecant is less than 0. Looks like an L, so it's negative. So if cosecant is negative, then so is its reciprocal, sine. And sine is negative in quadrants 3 or 4. Okay? In 3 or 4. And here, cosine is negative, so cosine will only be negative in quadrant 3, not 4, because in quadrant 4, cosine is positive. I'm almost done.
I have 2 meetings and
Okay, so last one. Sorry, you guys. This is a recording. Part G. In which quadrant does theta lie? Go ahead and try this one here. Press play when you're ready. All right, cosine can only be less than 0 or negative in quadrants 2 or 3. Okay, so we narrowed it down to 2 quadrants, okay? Over here it says cosecant is greater than 0, so cosecant is positive. But if cosecant is positive, so is its reciprocal, sine. So where is sine also positive? That only works in quadrant 2. Here's the last one. I thought that was the last one. Try this one out and then press play when you're ready. Okay, so here secant is less than 0, so secant is negative. So that would imply that its reciprocal cosine is also negative. And where is cosine negative? Quadrants 2 or quadrants 3. So we narrowed it down to 2 from 4. So we got to narrow it down a little bit more. We know that cosecant has to be greater than 0. Or in other words, cosecant has to be positive. But if cosecant is positive, then so is sine, because that's the reciprocal. And sine can only be positive in quadrant 2 in this case. So it's quadrant 2. Okay? Try it out. Again, use logic. Don't just guess, because that's not the purpose of it. You want to be able to explain and justify exactly where you are. Okay? Cool.